Hello, this is Mr. Fallen. I'm going to attempt to record a video here. I've made a couple of attempts, but I just keep running into technical difficulties. I think I've got it all worked out now, so let's see if I can do a few examples here. Now, this is from section 1.3 of the Intermediate Algebra course, so these are some problems that you should come across on your homework. I'm sorry, this is kind of a new system for me, so okay, so I think I'm ready to write. So there's just a few word problems here. What I'd recommend for a lot of these word problems, if it is referring to like a geometric shape of some kind, draw a picture to help you figure out how to piece it together. If it's a problem like the one we see here, I recommend doing what I call a hybrid statement. So I'll illustrate what I mean by that as we do this example. So we have the following problem. An appliance store decreases the price of a 19-inch television set 28% to a sale price of $450. What was the original price, right? So we know it's on sale for $450, but originally it was more than that. And we know the discounted percent is 28%. And we want to work backwards to find what the original price was. A common mistake students will make with this problem is just grabbing the numbers that they see without thinking about how they should interact with each other. So many students will take 28% of $450, but that is not what the 28% applies to, right? The 28% applies to the amount that the TV was originally selling for, right? So it's not 28% doesn't apply to the sale price, 28% applies to the original price. So we don't want to take 28% of the sale price. That would not be the right thing to do. So to help us figure out how the different components of this problem fit together, I recommend doing a hybrid statement, which is a statement that's composed of words but related with mathematical symbols. All right. So if you think about how sales work, what you have is your original price. Sorry, my handwriting might be a little bit bad here. You have your original price of your item, and then a discount is applied. So we're going to subtract off that original price, a discount, and that is how you arrive at the sale price, right? So anytime an item is put on sale, this is the relationship between the different elements of the situation, right? So we're using words to represent the different pieces of this equation, but now we want to convert those words into algebra so we have an equation to solve. And we'll start with the thing that we know, which is the sale price. Right? We know the sale price of the TV is $450. Right, so we're going to put that there. I'm going to leave off the 0.00. We know something about the discount. What we don't know is the actual amount of the discount. I don't know if it was $50 off, $75 off. I don't actually know that much information, but I do know that it was 28% of the original price. Right? So the discount's 28% of the original price. I'm just going to put original here. And the original price, I actually know nothing about. I'm given no information about it whatsoever. And so my advice on these word problems, and this will extend throughout the rest of the course, anytime you're doing word problems, let your variable be the thing that you know the least about. So I'm going to let X represent the original price of the TV because that's the thing that I know the least about. Copy down the minus sign. The discount, I have a clue about that. It's 28%, which I'm going to write as 0.28 of the original price, which I decided to call X, right? So the original price here, I'm representing with the variable X. So I'm going to use it again here. I'm going to use X again here because it's representing the same thing. And that will equal $450. So this is how everything relates. And so now I have an equation to solve. And this is kind of a weird situation with these two terms. These are like terms, right? We have 1x, and we want to subtract the 0.28x. And so the way we do that is we subtract the coefficients. So just like if you were doing 5x minus 2x, right? That would simplify to 3x. And how do you get that? You subtract the coefficients. 5 minus 2 is how we get 3. We're going to do the same thing here. We have 1 minus 0.28, which is going to give us 0.28. Let's see, I wasn't ready to do any kind of arithmetic. I'm pretty terrible at it, so I think they'll give us 0.72, and then we copy the x down, just like we did over here, right? Copy the x over, equals $450. And now to solve this equation, I'm sure you know what to do from here. You're going to divide by the 0.72 on both sides, and you will get an answer for x. Sorry, it's supposed to be an arrow. Let me try to draw that again. I'll just draw a one-legged arrow here. And so we'll get x equals, I don't have a calculator with me. Let me see. Here's my phone right here. So let me go ahead and calculate that real quick. We will get 450. You probably already figured it out before me. 450 divided by 0.72, and I get 625. So the TV was originally $625. And so that's what they're asking for. So this isn't always the case, but in this case, X is the thing that they want us to find. And so that's our answer, $625. All right, let's move on to the next example. All right, so this one we have the perimeter of a playing field for a certain sport is 260 feet. The field is a rectangle, right? So we have a shape there, and the length is 40 feet longer than the width. So find the dimensions of the rectangle. So this is a problem where we don't need to write a hybrid statement because that isn't really going to help us. What will be helpful here is drawing a picture. So anytime they refer to some kind of geometric shape, draw a picture. I'm doing my best on this tablet to draw a rectangle. Didn't come out as well as I would have liked, but there's my rectangle. And anytime you have a rectangle, it has two dimensions that we usually denote, which are the length, which I usually think of as the longer side, and the width. Right? So we have a length and a width here. Let me try to redo that L. All right, length. I kind of did a bad job of it again. Length and width. Okay, so and we know the perimeter. Now remember, perimeter is the distance all the way around. So if I were to start like in the corner right here and go all the way around the rectangle, that's the perimeter. And we're told what that is. The perimeter is 260 feet. So I'd like to kind of write that in the middle of my shape. And so we're told the length is 40 feet longer than the width. So I have to decide what my variable should represent. And we have length and we have width here, but we want to kind of decide on one of those to be our variable. We don't want both of them to be our variable. Our variable, remember, should be the thing that we know the least about. So if you think about this sentence here, the length is 40 feet longer than the width. Which one do we know the least about? We know the least about the width. And so I'm going to call that X. You could call it W, but I'm already using W over here, and I want to show that I've made a decision here. I've decided to let W be my variable, but I'm going to call it X instead of W, because that's the one I know the least about. I have some information about the length. I'm given a clue here. The length is 40 feet longer than the width. And so I'll use that clue to help me represent the length using the same variable. The length is 40 feet longer than. The longer than means we want to add 40 feet to the width, right? And so that's supposed to be a plus sign. That kind of came out sideways. I'm going to try that again. Plus, all right. And so we'll take the width, which is X, and then we'll add 40 feet to that, and that is the length. All right. And so I want to add up all four sides because that's the information they give me. The perimeter is 260, so that if I add up all four sides of the rectangle, it should add up to 260. For a rectangle, if you remember, opposite sides have the same measure. So if this side is going to be represented with an X, then the opposite side can also be represented with X. If this side can be represented with X plus 40, the opposite side can be represented with X plus 40. And we'll add up all four of these sides, and we know it has to add up to 260. And so that'll be my equation. So I'll do it over here. I'll start just like I did in this corner here. I'll take the first side, which is X, plus the bottom side here, which is X plus 40, plus the right-hand side here, which is another X, plus the top side here, which is X plus 40. So I add up all four of those sides. So let's see if I can fix that. All right, and that has to add up to 260 according to the problem. All right, so there's my equation. So let's go to solve this equation. We'll combine like terms. We have 4x's here, so 4x, and then we can add the 40s together, and so that gives me 80 equals 260. And from here, again, I'm pretty sure you've probably seen this before, especially if you're working on section 1.3, you would have already done the section about solving equations, section 1.1, and this is the kind of equation you would have solved in that section. So hopefully you're feeling comfortable with that. Subtract 80 there, we will get 180 from that. And then we'll divide by 4, and hopefully I can manage this arithmetic without having to hunt down my calculator again. And so we're going to get x equals, dividing by 4 here, 4 goes into 18 4 times, and that gives me a remainder of 2. Bring down the 0, so I have 20. 4 goes into 20 5 times. All right, so we get x is equal to 45. All right, now what we need to do is input the information into Math Excel. So make sure, because sometimes they'll change it up on you, make sure you have the right information and you're typing it into the right box. Because here, they're asking for both dimensions, right? They want to know the length and they want to know the width. What we have found, if you remember back, looking back at our diagram, we have found x, which is the width. So you want to remember what x was representing for you so you can make sure you type it into the right place. And the width is the first thing they're asking for, but sometimes they will switch it around. They'll ask for the length first to throw you off. So pay attention to that detail. X is the width, and that is what they want to know first. So you would type in 45 here. 45 is the width, and that is in feet. Because the perimeter is in feet, the width would also be in feet. And that's what the drop-down menu is for. So this drop-down menu, you're going to want to select feet. One of the other options they'll have is square feet, and that's not the right option here because this is not an area. You use square feet for area, you use cubic feet for volume. For dimensions, you just use feet. We also need to find the length, and we can unlock that information as well by going back to our diagram and taking x equals 45 and plugging it in. And so we find that the length is going to be 45 plus 40, which gives me 85. So we're just going to add 40, right? The length is 40 more, which means the length has to be 85 feet is what you'd want to select there. All right, so there's my final answer for that one. Let's take a look at the next example I have here. So I tried to find an example of each different kind of problem. This one's kind of interesting. So a piece of wire, 64 centimeters long, is cut into 2 pieces, each to be bent to make a square. The length of a side of one square is to be 2 meters longer than, that's this one here, 2 meters longer than the length of a side of the other. Right? So again, of the two, which one do we know the least about? We know the least about the smaller one. We know the bigger one, we want it to be 2 centimeters longer than the side of the smaller one. So how should the wire be cut? So what's interesting about this is, while this diagram is kind of helpful. So for example, we can go ahead and finish labeling this. It's a square, which means all sides have the same measure. So if this side is going to have measure x, so will all the other sides. These will all be x's. And if this is going to have measure x plus 2, all the other sides of the square will also have a measure of x plus 2. I'll just put that one right there. However, this is all being constructed from one piece of wire that we're cutting into 2 pieces. Doesn't mean we're cutting it in half though, so you have to be careful. A lot of students will assume if you're cutting something into 2 pieces, you cut it into exact halves. But that is not the case here. One piece is going to be larger than the other piece for this configuration to work. So I would again draw a picture of the wire that we're going to cut. And it's just one length of wire that hasn't been bent yet into a square. It's just a straight piece of wire. And we're going to cut this wire into 2 pieces, not in half, so don't put it at the halfway point. But let's say we cut it right here. All right. And this side will be used to make the larger square, the square that has x plus 2 as its side. And let's see, what color should I use here? This side will be used to make the smaller square. Now, if you look at the diagram we have here, if I want this to be able to be bent into this shape here, the total length of this piece of wire would have to add up to the perimeter of this square if I want to make sure it can bend into that shape. And that's 4x's that we have here. So this length of wire, in order for it to fit into this shape, would have to have a length of 4x. Right. Same reasoning applies to the bigger square. If I want the longer piece of wire to bend into the bigger square, I would need a length of wire that can cover all four sides, which is 4 of these x plus 2's. So I want 4 of these x plus 2's, and because there's two terms there, we have to use parentheses to multiply that by 4. So I'm going to take the x plus 2, multiply it by 4 by putting it in parentheses. And so that's how long this piece of wire would have to be bent into this shape. And what we know about the wire altogether, the entire length of the wire, is that it's 64 centimeters long. And so if I take the larger piece and the smaller piece together, it would have to add up to the total length of the wire, which is 64 centimeters. So that is your equation. You're going to take the length of the larger piece, which is this 4 times x plus 2, plus the length of the smaller piece, which is 4x, and that has to add up to the total length, which is 64. And so ultimately, with all of these word problems, the goal is to set up an equation that we can solve. Because once you have the equation set up, you know how to solve it. We have nice processes in place. We've studied it extensively, that we know when we have an equation like this, we know exactly what to do with it. And so that's the goal here, is to get an equation that we can solve. All right. And so let's solve this equation. The first thing we'll have to do is distribute the 4. All right, so we'll get 4x plus 8. This 4x just copies down. The 64 just copies down. And then we'll combine like terms just like we did before. We'll have 8x plus 8 equals 64. We will subtract 8 from both sides. So we'll have 8x is equal to 56. And then we will divide by 8 on both sides. I'll see if I can fit that in right here. And so what we end up getting is that x is equal to 7. And the units on that will be centimeters, right? And so 7 is what x is equal to. But be careful not to take this number and just plug it into Math Excel right away. You want to make sure that this number actually is the answer they're looking for, and it actually isn't in this case. X is the length of the side of the smaller square, but the question's asking what is the length of the shorter piece of wire that we're using to construct the smaller square, which is this right here. So that is what Math Excel is asking us to find. What is the length, what is the entire length, I shouldn't say entire length, but what is the length of the shorter piece of wire that we're cutting? And so to find that information, we're going to take x equals 7, and we're going to plug that in to where we want to find the information. If this is the information we want, that's where we're going to plug in x equals 7. And so I'm going to take 4 times 7, which is 28. And so 28 centimeters is the length of the shorter wire. And I don't think it's going to ask for it. Maybe it does. If it asks for the length of the longer wire, you can plug in 7 here to find that. So you get 7 plus 2, which is 9. 9 times 4 will be 36. Or you could take the total length of the wire and subtract 28 from it to find the longer length. Right, so 64 minus 28 gives me 36. And this would be the length of the longer wire. And this is the length of the shorter wire. All right, good. So I think I have a couple more examples here. So I'm sorry, I don't want this video to be too long, but I wanted to make sure I addressed every different kind of problem. So this is another one that's a little bit different than the ones we've done so far. Find 3 consecutive odd integers such that the sum of the first, so sum means we're going to be adding, of the first 2 times the second number and 3 times the third number is 46. So we want to add these 3 things together. In fact, I would recommend using a hybrid statement for this one. We want to add the first number plus 2 times the second number plus 3 times the third number. And that will add up to 46. So there's my hybrid statement. I'm using words to represent these different numbers. Now I want to convert those words into algebra, so I have an equation I can solve. So I'm going to convert these into variables and whatnot. In this case, my advice earlier was let your variable be the thing you know the least about. In this case, we have the same amount of information about all three of these. There isn't one we know the least about. It's equal for all three of them. So it really doesn't matter which one you let x represent. So usually the conventional thing to do is to let x represent the first one. So I'll let x be that one. Now if the first number is going to be x, the second number has to follow a certain pattern because we want these three numbers to be consecutive and odd. So an example of what that would look like, so this always helps me to think of a hypothetical. What might this answer look like? It could be 3, 5, 7, for example. 3, 5, 7 is an example of three consecutive odd numbers. So the second number, 5, the middle number, is 2 bigger than the first one. Even though they're odd numbers, the middle one is 2 more than the smallest one. So to represent the second number, it'll be 2 bigger than the first number, so I'll represent it with an x plus 2. Plus 3 times the third number, again looking at our hypothetical answer, it's 4 bigger than the smallest one, right? We want to define it in terms of the smallest one because that's the one, okay, I messed up there. I don't know if it'll let me move it. I'm sorry, the screen might have jumped on you there because I accidentally grabbed the wrong thing. So if x is going to represent the smallest one, we want to define the largest number in terms of that one as well. And so the larger one is 4 more than the smallest one. And so we'll represent the third number as 4 more than the first one, so x plus 4. And that's still equal to 46. And there is our equation. And once you have an equation, you solve the equation to get your answer. So we'll have x plus 2x plus 4, because we'll distribute the 2, plus 3x plus 12. I almost put 6 for some reason, but 12 would be the right thing there, equals 46. Combine like terms. Let me switch to a different color to make it easier to read. So we'll have 6x, combine the numbers together, plus 16 equals 46. We subtract the 16 from both sides. We'll get 6x is equal to 30. And it really has to work out to be a nice answer because it says up here, I don't know why I put 5 because that's going to be the answer. Sorry about that. We're going to divide by 6. The answer comes out 5. It has to work out nice because it says they have to be integers, which means they have to be whole numbers. So if this doesn't work out to be a whole number, you did something wrong and you have to go back and try to fix it. All right, so we end up getting x is equal to 5. All right. And so it's pretty close. My hypothetical answer is pretty close to the right answer. 5 is the first number in my set. The second number will be 2 more than that, which means it'll be 7. And the third number will be 4 more than 5, which means it'll be 9. So 5, 7, 9 would be my 3 consecutive odd integers. All right, got one more example here, and this one's actually pretty easy. Jen's motorboat travels at a speed of 12 miles per hour in still water. Booth River flows at a speed of 4 miles per hour. All right, so we have this. Let me draw it like this, I guess. So you have this river, and the water is flowing at 4 miles per hour. So this is the current. The current has a speed of 4 miles per hour. Jen's boat is in this water. So here's the boat. How long will it take Jen to travel 16 miles upstream? So that is a distance, right? Upstream means you're going against the current. So we're talking about this direction this time. So her boat travels 12 miles per hour on its own, right? But the current is going to work against it at 4 miles per hour. So the net speed of the boat will be 8 miles per hour when she's going upstream. So we're talking about speed, right, which is represented with r. We're talking about a distance of 16 miles, and we're trying to find a time. How long will that take? And so there's a formula that will connect all the pieces together for us. And it's a very simple formula. It's D equals RT. You've probably seen it before. And that's all this problem is using this formula, plugging these numbers in, and solving to get your answer. So this is what we call in mathematics plug and chug. Right, so we're going to plug these numbers in. The distance is 16 miles. The speed is 8 miles per hour. And we don't know the time. That's what we're trying to solve for. And we can get that pretty easily here by just dividing 8 on both sides. And we get 2. So going upstream, right? So this is the upstream case. It would take 2 hours, right? And it's hours because the units here are in hours, so our time is going to come out in hours as well. And so that's what we would type into the box here. For downstream, let's try that one real quick. All right, so we have the same formula applies, D equals RT. Fancy name for this is uniform motion. That's the formula for uniform motion. The distance, they stuck with 16 miles, so we'll use the same distance here. All right, 16 miles. But this time the speed will be different because this time, I don't know what color, I guess I'll use red this time. We're going downstream, right? Downstream means we're going with the current. And so if we're going in this direction, the boat on its own would go 12 miles per hour, but it's going to get a boost of 4 miles per hour from the current. And so the net speed going downstream will be 16 miles per hour. Right? And so we'll put that here for the speed. We're looking for the time. And so we solve by dividing 16 on both sides, and we get 1. So nice of them to have the problem, the numbers work out really nice. It didn't have to be that way. They could have gave us, some numbers where we got some decimal times, like 1.5 or something like that. But these worked out pretty nice. All right, and so it'll take 1 hour to go 16 miles downstream with the current boosting us.